Hey, welcome to Blue Pen Land here. Let's do some simple harmonic motion ones. The first question on this assessment is always a question that uses this formula. Okay, V is plus or minus. So this is not really a velocity equation, right? Omega square root of minus the position squared, right? So this is the amplitude. That's where you happen to be. This just comes from energy, but the IB has come up with this, I don't know, kind of a nifty sort of thing here, right? So the other formula we're going to use with regularity here is that omega is 2 pi divided by the period. So that's my first step here, right? Is I'm going to go, we have 0.234, right? So omega is 2 pi divided by, ta-da, right? And then we want to find, when it's at 0.118, what's its speed, right? So now we just plug it into this, right? Okay, so the velocity is, or the speed, right, plus or minus 2 pi over, that's my omega, right? And then the square root of, here's our amplitude, right? So that goes in here. Okay. So 0.470. Let's square that minus 0.118 squared, right? And now we're all set. Now we can calculate that thing, right? Okay, so we go 2 times pi divided by 0.234 times the square root of, holy parentheses, Batman, 0.47 squared minus 0.118 squared. All right. Ta-da. I get 12.2158. Right, now it could be going either way, right? Because at this amplitude, at this position, right? It's like, here, let's draw a little picture, right? Here's the middle. Here's x equals 0. Here is 0.476. Here's negative 0.476, right? Or 0.47, sorry. Positive 0.47. It's here is roughly where it is, right? It could be going this way or this way. It could be on its way out or on its way back. We just don't know. If you tell me a position, I can't tell you, right? So 0.2158 meters per second. So there's my velocity, right? And then what is its acceleration? Acceleration is just simply negative omega squared x. That's a formula in the data packet. This is in the data packet. To that, right? So I'm just going to go, it equals 2 pi over, right, equals that, negative that squared, right? It's not the, yeah, anyway, the opposite of this squared, right? Times x, which is 0.118. Okay, so parenthesis 2 times pi divided by 0.234. That thing squared times, and I get negative, wow, negative 85.08. Okay, so regardless of whether it's moving to the right or the left, okay, it is accelerating to the left. It's accelerating toward the center, right? All of these things will have negative accelerations. All of these guys will be accelerating to the right. And that's kind of the weird thing. That's the thing to wrap your mind around, right? If it's moving toward the equilibrium, it's going faster and faster. If it's moving away from the equilibrium, it's going slower and slower. Regardless, the acceleration is exactly the same. Okay, and that's simply why. Why is that? Because F equals ma. Where can I write F equals ma, right? And the force is also equal to kx, negative kx. That's the elasticity formula, right? Hooke's law. And then so the acceleration is just always minus k over m times x, right? Which would imply then that omega is actually, since this is omega squared, right? Omega is actually the square root of k over m. This would be the most useful formula they could put on the data packet, but they don't. All right.